Good morning, myself Sanjeev Kumar. Today in this lecture we are going to discuss types of DC machine losses. Now basically DC machine losses are three types. First one is copper losses, second one is iron losses, third one is mechanical losses. So copper losses are again divided into three types: armature copper losses, series field copper losses, and shunt field copper losses. And iron losses are divided into hysteresis losses and eddy current losses. And mechanical losses are again divided into friction losses and windage losses. Now, what is meant by copper losses? What is meant by iron losses? And what is meant by mechanical losses? So first one is copper losses. So these copper losses are mainly due to the copper resistance. So it is nothing but also called as a ohmic losses. So each material having some resistance, whenever a current flowing through that winding or conductor, heat will be dissipated. So these copper losses, you can also call it as a ohmic losses or I square R losses. Now these losses in armature winding, and in series field winding, and also shunt field winding. And the second one is iron losses. So iron losses are depending upon material and depending upon the reversal of magnetic flux. So behavior of magnetic flux, and also due to the construction like laminations, again we are having the two types of iron losses. So this is also called as the core losses. These losses are occurred in core, that's why they are also called as core losses. And the third one is mechanical losses. So this is purely mechanical depending upon friction. Nothing but when the motor is running with the friction, the speed will be less. There is the end cover, the shaft is extended into the bearings. So without proper lubrication there may be a friction. And the windage losses. Windage losses are nothing but air resistance. When the shaft is moving, some opposite air is coming to the shaft, so that the shaft speed may be decreases. So friction and windage losses are under mechanical losses. So with these two also there is some power losses. So that's why these are considered under the mechanical losses. So major types of DC machine losses are copper losses, iron losses, and mechanical losses. Again, copper losses are armature, series field, and shunt field. Iron losses are hysteresis and eddy current, and mechanical losses are friction and windage losses. Now we will discuss the each and every losses, and also we write the formulas for them. Now we will discuss the copper losses. So copper losses also called as I square R losses, and also called as ohmic losses. I square R losses and also called as ohmic losses, since the losses depend upon current flowing through the conductor and resistance. So we know that armature windings, shunt field winding, and also series field winding is made up of enameled copper. Enameled copper. For small machines it is also aluminum. We know that copper is a good conductor of electricity. Copper is a good conductor of electricity, but still it is having some resistance. So due to this resistance there is a power loss will take place. We know that the power loss is equal to I square into So since the current is very high, power loss is also increases. Now due to this I square R, we are having the ohmic losses. We can also call it as heat losses. So these losses always dissipated in terms of heat. So that's why they are also called as the heat losses. Now the armature copper losses is equal to Ia square Ra. Current flowing through the armature square times into resistance of the armature. Similarly, shunt winding losses or shunt field copper losses, ISH square into RSH or V into ISH. I square or V into I. Now this is the shunt field copper losses. Similarly, series winding losses is equal to ISC square into RS. Current flowing through the series winding into series winding resistance. Similarly, interpole losses are there. So interpole losses, you can also take it as Ia square into R. So interpole resistance also we are considering, and it is nothing but Ia square into R. And brush losses you can also consider as Ia into brush contact drop. So current flowing through the winding is Ia armature, and the brush contact drop, or sometimes interpole resistance and brush contact drop resistance also considered, since it is a carbon brushes. So these are the major copper losses and their formulas, so that we can calculate the copper losses by using these formulas. And the next one is iron losses. We know that iron losses are also called as core losses. Why they are called as core losses? They are occurred in the core. So that's why they are called as the core losses. We know that iron losses are two types. So iron losses are two types. So first one is hysteresis losses, and second one is eddy current losses. The second one is eddy current losses. Now first one is hysteresis losses. What is meant by hysteresis losses? Now these hysteresis losses are mainly due to the reversal of magnetic flux. So flux is always reversed. Due to the reversal of magnetic flux, these losses will occur. So why the reversal of flux takes place? Now if you take the magnetic pole, you are having the north pole and south pole. So flux is coming from north pole to south pole, and this armature is rotating in this. Now always this flux try to cut the armature conductor so that EMF will be induces. Now while the cutting action takes place, so since it is a two pole, so if you consider four pole two pole machine, so the poles, the magnetic flux always reversed. So since the magnetic flux is reversed, so there is some losses takes place. Okay, so there is some losses takes place, and this conductors cutting the flux, when the flux cutting action takes place, So there is some losses will take place due to the reversal of magnetic flux. So magnetic flux each and every time has to pass through the north pole, south pole, again north pole and again south pole. So alternatively these poles are every time changes, magnetic flux cutting action also changes. So if there is no rate of change of flux linkages, so there is no induced EMF. Every time the flux cutting action is going to be changed, the rate of change of flux linkages changes. So this will causes the reversal of magnetic flux. This flux is going to changes every time. So due to this reversal of magnetic flux, some losses will take place. So they are called as the hysteresis losses. And also we can take the hysteresis property. So hysteresis property, what is meant by hysteresis property? When a magnetic material is magnetized, then it is going to be magnetized in some way, so that when it is demagnetized, the magnetism may not be retained. So that there is a concept of BH loop. So due to this, the reversal of magnetic flux takes place and there is some losses called as hysteresis losses. Now for this hysteresis losses, can denoted by WHE. We are having some formula. So this formula is WH is equal to eta into H into B max. B max to the power of X into F into V. Whereas eta H is the steam edge constant and B max is the maximum flux density and X is the steam edge exponent varies between 1.5 to 2.5 and F is the frequency of magnetic reversal, and V is the value, volume of core. We can call it as the volume of the core where hysteresis losses are occurring. So that's why you can call it as a core losses. Now this is the formula for hysteresis losses. So generally you can take X is equal to 1.6. Now depending upon material, the X, which is called as a steam edge exponent, also going to change. Now this is the formula for hysteresis losses. Now by using this we can calculate the hysteresis losses. And the second type of iron loss is eddy current losses. Now what is meant by eddy current? It is the current induced in the laminations of a core. We know that armature core is made up of laminations, steel stampings. So these laminations, or it is not a solid one, all laminations are separated by varnish. So these laminations induces a current that is called as the eddy current. So why currents are induced in these laminations? So this armature winding, armature core both induces the EMF. We know that when a conductor placed in a magnetic field, so EMF will be induces in this conductor. With respect to conductor, we are also having the core. So when the core is placed in this magnetic field, the EMF also induces in this core. So since it is a lamination, so it is having a only single path to flow in this. It is a not solid lamination. It is not a solid core. It is a single lamination. Number of laminations are there. So the current have more path available to flow through except this single lamination. So this current is flowing through only this particular lamination, and this wastage some power, and this current is called as the eddy current, and due to this the losses are called as the eddy current losses. So what is meant by eddy current losses? When the armature core induces some currents when it is placed in a magnetic field with respect to armature winding, the current is called as the eddy current. Due to this eddy current, there is a losses. Those are called as eddy current losses. Now we will have the formula for eddy current. So WE is the eddy current losses. We will indicate eddy current losses. Now WE is given by eta into E B max square into F square into T square into V. Now this is the formula for eddy current losses, whereas eta is the against Steeman constant and B max is the flux density and F is the frequency and T is the thickness of lamination, and V is the again value. So this formula is used to determine the eddy current losses. So eta E into B max square into F square into T square into V. So B max square and F square both are very important, and also thickness of lamination is also very important. As thickness increases, eddy current losses also increases to very high value. So thickness also should be maintained very low since it is a square term. So eddy current losses will decrease. So hysteresis and eddy current losses are types of iron losses. So to increase the efficiency, these two losses always kept low value. So efficiency of the machine is going to increase. And third one is mechanical losses. Now the mechanical term itself indicates due to the mechanical parts, that means the parts of a machine. So again these are two types. The first one is friction losses. So friction losses basically due to the bearings and again commutator segment brushes. So bearing, when you place a shaft to the bearings, if the proper lubrication is not done or any dust particles are formed on that particular grease or lubrication, so there is a friction in the bearing which causes the motor speed to reduce and also make the noise. So due to this, there is a losses called as friction losses. Similarly, brushes. So the brushes are placed on commutator segments. If the brush tension is not properly adjusted, there is a wear and tear on the brushes which causes the losses and also makes a spotting at the segments. So this brushes also comes under the mechanical losses which will makes the wear and tear. So friction losses, bearings and commutator brushes. Now the second one is windage losses. So windage losses. Now windage, wind itself indicates air. So due to air resistance, the shaft speed is going to decreases. Or in the opposite direction, if the motor is rotating or generator is rotating, due to that air resistance, the speed of your shaft is going to decrease. We are providing the ventilating ducts and armature through the end cover and armature core. So the air is actually flowing into the generator to cool the armature venting. So if the air flow is in not correct direction, it is flowing opposite to the rotation, then there is a losses called as windage losses. So these are due to air resistance. You can call it as a air resistance. So this losses also causes some power losses. Since these losses are very less affected than iron losses and copper losses, so very less percent is given to these two types of losses. Now these are the mechanical losses. Now overall armature and DC machines having three major types of losses: copper losses, iron losses and mechanical losses. So in this iron losses and mechanical losses, iron losses and mechanical losses combinedly called as stray losses, combinedly called as the stray losses. So mechanical plus iron losses, so there is no electrical current involved in this, only the mechanical parts as well as the manufacturing. Due to the material, these losses are called as the stray losses. And iron losses plus mechanical losses plus shunt field copper losses, shunt field copper losses together is called as the constant losses. Constant losses or standing losses. So why they are called as a constant losses? For a shunt machine, the shunt field winding flux is going to be constant. Now since the field current is constant, shunt field current ISH, the shunt field copper losses are also constant. So generally the field flux remains constant until there is a sudden changes in the load. So shunt field copper losses also assumed as constant. So what is the shunt field copper losses? ISH square into RSH or V into ISH. So this remains constant. So iron plus mechanical plus shunt field copper losses in which flux is constant together is called as constant losses, and iron plus mechanical losses are called as the stray losses. Now if you distribute the losses among the copper losses, mechanical losses and iron losses, so generally the iron losses and We'll make it. So copper losses at 30 to 35% of the full load losses. 30 to 35% of the losses due to copper or ohmic losses or I square losses. Next, iron losses. Iron losses 20 to 30% of the full load losses or total losses. Total losses. Next, mechanical losses 10 to 15% of full load losses. Now we can see here, due to electrical current, these losses. So what is the copper losses? Copper losses are nothing but I square R losses. So when the current increases, copper losses also increases, since current is the square term. So you have to keep in mind that to reduce the copper losses, the armature current has to limit it within the temperature limit so that the copper losses will be less. And by using the proper material, and so the reversal of magnetic flux and the laminations, eddy current losses are also reduced, so it should be kept low value, so efficiency of motor or generator increases. And the mechanical losses are less, 10 to 15%, by making the regular maintenance, lubricating and greasing, and also proper placing the motors or generators. Mechanical losses are also reduces. The major losses are due to copper losses. So by using the high grade enabled copper, low resistance, the copper losses are also going to be reduces. Now these are the various losses in DC machines. Now we will make some different conditions and efficiency relation among all the parameters.